I'm starting to work down in the bottom corner here by the power transformer. First thing I did was check out this big dog bone resistor, which is original as near as I can tell. And it's supposed to be 12K, like the schematic indicates. That's how it's marked, but it's measuring closer to 18K, so I'm going to replace that. And even though this new one is much smaller, this is, I'm pretty sure, a 2 watt, and this is a 3 watt, so this is actually more than sufficient, even though it's much smaller, because my materials can handle the higher temperature. And attached to that was this 470K. I tried measuring it in the set and I was getting anything, so I took it out. And yeah, it is completely open. Don't think I've encountered that before. It looks fine, not discolored or anything, but completely open. So I'm going to have to go through and check all these resistors really carefully. Starting to make some progress putting new parts in. I discovered something. At first I thought all the wiring in this radio was cloth covered. It still had some flexibility. However, I knew that radios from this era, at least Philcos from this era, had rubber wiring and it gets extremely brittle and it all falls apart. Well, this has the same problem. So when I started moving this wire, I noticed all the insulation's falling off. And this is the same. So about half of the wires are like that. Certainly have cloth in here. But like here, and a few others in these guys. But some of them are most definitely crumbly kind, so I will be replacing those. You have two basic options when it comes to that wiring. You can replace it with a modern PVC insulated wire. I got a supply, a bunch of colors, so I can replicate. As I've got yellow, green, and orange, so that's no problem. Or you could cut one end and slide heat shrink tubing over it. But, well, I guess I could do a mix of both, because I do actually have like some red and some green. So like this green wire here, because the wires otherwise are in fine condition. So I could go along and break all that off, and then slide this over. It's kind of a matter of what you got on hand and which is the most expedient to do, I suppose. But one way or another, it's got to be re-insulated because this is not a safe thing at all. Here's a little progress update. I installed a new line cord. I like the way RCA did this, where they have two holes on the back, so split out the zip line cord and have one go through either hole, and then I put a underwriter's laboratory knot on the other side, and installed a fuse. Goes up to the power switch. Alright, then working our way up. Some of the wires, like this one, which is just a straight piece of wire across, I figured it was easier just to slide some heat shrink tubing over it to replace the crumbling insulation. So I have other areas like here. I'm just going to install some new wires. What I'm doing right now is I've worked my way up to here to the first of these lozenge type caps, and I noticed this one was pretty melted on the side. I'm thinking that happened back in the day because I sure didn't do it. Well, that makes me a little suspicious, and this gives me a chance to test it out. So I had cleaned everything else off of this terminal where it would connect over here, so I got one end free. So it's disconnected from everything else, which you want to do when you're testing it to make sure that nothing else is interfering with your testing. So let's see what we get. So first, leakage. Well, it certainly isn't leaky. And for capacitance, C3 range, yeah, that's pretty close, pretty much right on the money, maybe a little high. I'm still inclined to replace it though, just because of the melted side. They could let environmental contaminants get in there, moisture could start seeping in. I don't know how thick that coating is. But it's encouraging, so There's a bunch of them up in here, and I don't want to replace all of them if I don't need to. Here's another progress update. Pretty much done up to here. Starting to work on that filter electrolytic 3-section capacitor now. And a few options. I could cut it open and drill holes through it and run leads through. I could unmount it and uncrimp it and restuff it. I could install a terminal strip. Plenty of room underneath this chassis. But what I'm finding very convenient is there are a lot of these tie points on this chassis. I'm guessing they use this chassis for other models. Something, because there's a lot of holes, unused holes. You can see you mount the whole new control up here. So in other words, there's plenty of room under here. And these bent over tabs here make a very convenient ground point, because this chassis seems to be copper plated, very easy to solder to. So for example, here's cathode bypass on the output tube, and here's one of the filter caps. So right off the rectifier tube for the positive, and then ground right to a convenient lug right there. So that's how I'm going to do it. So I just have one more section left to do here, and then this guy is already a discrete cap. So I think I'll probably have an axial cap handy. Otherwise, I'll use a radial and just bend leads as needed. But what I thought I'd do right now, since I've got this section, I've already rerouted it. I'd put on a capacitor checker. By the way, as far as like placement, this is actually better than the way they had it. So for example, this is the main filter cap right after the rectifier tube. So this guy. So the way the original rerouted it, there was a wire coming out here, coming off the lug, through a hole in the top of the chassis, running on the top of the chassis, and then coming down through a hole here and connecting to that tube socket. Well, now I've got the cap, like as physically close as you can possibly get to that tube. What that means is you get less impedance. So before there was this wire here, which would add some resistance, some inductance to get up to that capacitor. It's a main filter cap, so you're going to have some surge current going back and forth through that wire. Radiate noise, and less of an efficient filter cap because of that wire. Now it's mounted right where it needs to be, similar to this output cap. Alright, so let's see what we've got on this guy. Should be 10 microfarad. I think 350 volt rated. Should be, because I got 325 here. Should be more like 375. You want to have some overhead. I use 450, so should be good there. Alright, well, let's see what we got. Well, leakage right away on the lowest setting. Leave it sit here a while, see if it has any potential for reforming. Not that I'm going to use it, I'm just curious. The fact that it's so leaky in the lowest setting, that wasn't a very good sign. Hey, there we go. Hey, how about that? And of course, we go up a notch and it's leaky again. But at least it's reformed up to 10, or 100 volts rather. And let's take a quick look at the capacitance. An eye deflection around here, which is around 11 or 12 microfarad, so potentially this cap could be used, something that will reform all the way up to 325 volts or better. It's been about an hour, and it looks like the cap has maxed out at about 417, 418. Which is far more than it needs to be rated for. If it's going to be 325 in normal operation, it'll be a bit of a surge on startup. So, yeah, perhaps this cap would work for a while. However, keep in mind that it's about 75 years old, and I wouldn't trust it in my radio for any length of time, so it's definitely going to get replaced. This third capacitor terminal had 2 wires and a component lead going to it, and I couldn't find a really good place to put in an electrolytic, so I decided I would go with a terminal strip. There's one wire, there's the other, and the third was this component here, When I unsoldered the lead, the resistor just fell in half. And I can see it looks pretty charred now, so that's definitely got to get replaced. Now, while I've been working on this, I've also been posting in the Antique Radio forum, and I just got a comment about these black lozenge type capacitors, and that others have had trouble with them, and suggested maybe I should just go ahead and replace all of them. Well, I'll definitely replace that one, and I'm going to go ahead and replace the rest of these caps and try powering it up and see how it goes, but I may very well end up replacing those as well. By process of elimination, I determined that that was R4 1000 ohms that fell apart. So, I'm curious, could this cap be shorted or excessively leaky, which would have caused that to burn out, or perhaps this resistor has issues. So it's going to be plus for the radio. So go up over here, over in 1000 ohm. So if there was too much current going through the resistor to cause it to fail or fall apart, either be going down through this capacitor or through this resistor. The 3.3K is a little sketchy looking too. It's up in here, a little hard to read. I could make out an orange, but not so much the other two colors. So I'm going to check that right now. And there's that 0.01. Looks a little melted on one end. Get out my capacitor tester and check that guy out. I'm going to be replacing all of them, but I'm just curious to see what if one of these might have caused that resistor to burn out. I finished with the recap. All the paper caps have been replaced and new electrolytics installed. There's a new 4 microfarad. The worst of the crumbling wiring has been replaced. What's left doesn't appear to be shorting to anything. I think I will go in and replace it later, but right now I'll try powering this radio up. So there's a few carbon comps still in there. The further I got, I started finding more resistors that were still within spec, so I left them in there. I've got my DC voltmeter attached to that cap right there, which is the one right after the field coil. That is the B+ supply to the set. And I've got my scope hooked up to this point right here with a 6 SA7. I figure we can see the local oscillator running at that point. If it is running, I got it plugged in, got my Variac set for about 115. So, without further ado, oh, and I've populated all the tube sockets. That's one thing I wanted to see. How high is that B+ when you first turn on before a set starts drawing power? That's over 450. I got 450 volt caps in there. I should probably go in 5 or even better 600. See if I have some on hand. Okay, and as it draws power, it pulls that way down. So this should be about 230 volts. Actually a little high. But it's good, nothing's shorted. We've got B+ going to the set for sure. We've got the speaker hooked in and the antenna. So a little something out of the speaker. Now I don't have the radio, and they don't clearly, or they don't state at all what position the switches are for. So we've got this, which I can see it's going right to this phono input, so this, I assume, is mode between phono and something else. I was thinking it might be tone control. There's several caps coming off of it. It's just a little hard to tell from looking at this what those various switch positions do. And likewise on this, which is a band switch, but it appears to have 3 positions, but this radio only has AM and 1 shortwave band. So what is the 3rd position for? I'm not sure, but anyways, it's on. Don't hear anything. I don't know, feel like the local oscillator's running, but maybe I got this in the wrong mode. It definitely changes. Still no local oscillator action though. So let's see about changing this. Oh, well, that did something. Alright, now local oscillator's running. Oh, nice clean sine wave. Is varying in frequency. Yeah, it's really loud. I guess this is probably the AM band.
Let me just step in real quick, and then Glenn, you go. John, in theory, I agree with you. That I mean,
we're at 1.17 megahertz. Yeah, this would be the AM band.
Ready to play on a Sunday or Sunday night or a Thursday.
So let's see what this switch does.
That should never happen. But boy, you see it with teams week after week.
Okay, that is a tone control.
Here's reality. You're talking about players that.
And then. Well, that's got to be the phono input. Maybe there's two positions for that. Maybe there's a tone control. Two positions on the phono jack.
Important and most impactful
And then here's the radio.
The great ones. Calling me to home. But if you want to have a go, so I told them a little bit about what the sound is.
There's nothing there.
Sit up here.
Nothing there either.
They still listen. You as a coach.
Might need to do a little deoxide on that switch. Appear to only have oscillator action on the AM band. And it craps out at the higher end. There's no oscillation, we don't hear anything.
The Bloody Mary makes you can't.
Well, actually, that would be the lower end. Right there. Well, I've still got some travel on this.
Football.
So, could be the 6SA7 I'm using. It isn't so hot. It's a used one. Tested okay, but best test is in the actual radio. Or there could be some parts that aren't so good under here, so those lozenge caps I still have in place. And the resistors have drifted a little bit, but not that bad. So I wouldn't suspect those. Could also have an open oscillator coil for the shortwave band, but the AM band is working to an extent. It just craps out at one end. And there's some caps I'm not wild about as well, like this guy, which appears to be an exposed mica cap off the end of that band switch. It might be a little leaky.